Reciprocal functions and negative powers. Reciprocal functions are those of the form where y equals k over ax plus b plus c, where k, a, b, and c are constant, and x is the variable. The graph of a reciprocal functions always has asymptotes. So asymptotes are of a curve is the line which the curve gets infinitely close to but never touches. So example will be to have a line drawn like that. So you go, say, let's say you have your x-axis and your y-axis, and your curve is approaching both the x-axis and the y-axis but never touches it. And there's another one here on the negative side, approaching it but never touches it. Infinitely close to but never. That means it goes to infinity and yet still doesn't touch it. So what happens here is those line of asymptote, we represent them by using a hidden line. So we use the line of asymptote will be drawn with a hidden line. And so that's the horizontal line of asymptote here. And the vertical line of asymptote will be this one here. So that's the vertical line of asymptote. So there are two lines of asymptote. There are two types of asymptotes. The vertical asymptote, VA, the denominator will be set to 0. Therefore, in this case here, ax plus b set to 0. And then you find the value of x. And that value of x will give you the line of asymptote. If x equals 0, then the line of asymptote will be 0. If x equals 3, the line of asymptote will be 3. It's a vertical line using hidden lines. If x equals a minus 2, then the line of asymptote will be minus 2. That's the line the curve will approach infinitely close to, but never touch. Horizontal asymptote is the second one, where y equals to c. Again, it says its name horizontal, so it's a horizontal line. It crosses y-axis, and that's the line of the curve will approach but never touch. So that's the asymptote that comes, two types of asymptotes that comes with reciprocal functions and negative powers. So let's look at negative powers. Negative power functions are those of the form y equals k over x to the power of n plus c. So let me write it out clearly. It's y equals k over x to the power of n plus c. Again, they have line of asymptotes where y equals to c is the line of asymptote, and where x to the power of n is set to 0. The bottom will be set to 0. That's the line of asymptote. Again, these are horizontal asymptote and these are vertical asymptote. There are two types of functions of the negative power functions. One with the odd functions, so if it is odd, and even function. So if it's odd, you get, for odd function, you get the situation that looks like this, because that's odd, right? So you get the situation that looks like that. But for even function, you get the situation that look like this. So you get, for even function, you get that and that. Or you might get the same situation that looks like this. For even functions, you get that. So you get that or that. So that's for even function. And for odd function, you get you get the other side of it here, that or that. So with these two types of functions you get, in this case here, this one is a is positive, so plus a, and plus a here, and this is minus a. A is the number in front here, so a will be positive, and here a is positive, so that's plus a, and this is minus a. So that's what you would get with an even function. To make it clearer, even function, you get a curve like that, where a is plus, and where a is negative, you get it like that. So it's denominator and numerator where a is plus, so that's a there. And for odd functions, you always get the positive a like that, and negative a like that. So that's what you get. Those are the two even, odd, and two evens that you get. And there are some example below here. Here are this example. This is negative here, so a is negative, and c is 0, so the line of asymptote, y is 0, so the line of asymptote will be y equal to 0. So it's the x-axis. So that's the line of asymptote because c is 0 here. The x is also 0 because if you set the denominator to 0, so if you set that to 0, right? If you set it to 0, you get x is 0, so the line of asymptote will be the line of asymptote where x is 0. So that's x is 0 there, so x equal to 0, and for this one is y equal to 0. So this is the horizontal asymptote, and this one here is the vertical asymptote. So that's the vertical, you set the denominator to 0, and then you work out x. And for the horizontal is the c here. That value of c will determine y equals to c is the horizontal asymptote. So looking at the two functions we got here, this is a is positive, so you can see the positive side here, which is this one here. It's an odd exponent to power minus 1, or to power 1 here, minus 1 there. So this is odd, 1 is odd, so you see that here and there. The reason why it's on this side and that is it's a twin curve. You can draw a straight line through that. The reason why you see on this side is because a is positive. So with this one, a is positive, so that's plus a. On this side here, a is negative, so that's that one here. You see a is negative there, so you can say a is, so that one is negative, so you can say minus a. Okay, and for this one, this is the even power, so that's even. When it's even, you always get the denominator only diagram, or the numerator only diagram, or the denominator only diagrams, graphs. And so we can specify here is the top one is a is positive plus a, and the bottom one is a is negative minus a. As you can see here, this is positive here, so you get these two here, and the line of asymptote is x equals to 0 and y equals to 0, right? Because set the x squared equals to 0, so if you set x squared equal to 0, therefore x equal to 0. So the line of asymptote is x equal to 0 here. So x equal to 0, and that's vertical because it's a vertical line, vertical asymptote. And for the horizontal asymptote, well, C is 0 because there's no C next to it. There's no, it's plus 0. There is C, it's plus 0. So the horizontal asymptote here is, that one is y equal to 0. So that's horizontal asymptote. So that's how you treat these two graphs, the reciprocal graphs and negative power graphs.